Differential equations are intimately tied to linear algebra. We must therefore present some definitions from linear algebra, since it is not a prerequisite for this class. A matrix is simply a rectangular array of numbers. So like this, or like this, for example. We surround them with either square brackets or parentheses. Unlike interval notation, there is no difference between these. It's a matter of personal preference. Matrices have rows and columns. We denote the size or the dimension of a matrix as the number of rows by the number of columns. So for example, this is a 2 by 3 matrix. A vector is a matrix with either one row or one column. In most fields of mathematics, including differential equations, we more or less exclusively work with vectors of one column, called column vectors. The main exception I can think of to this is probability, where row vectors are common. When we are handwriting, we denote vectors as letters with dashes above them. In typeset formats like your textbook, we use bold letters. We can do a basic arithmetic with matrices and vectors in fairly straightforward ways. If two matrices are of the same size, for example, these 2 by 3 matrices, we can perform matrix addition. This is done component-wise, so we'll add the upper left components, the upper center components, the upper right components, and similarly with the second row. We can multiply a matrix by a real or complex number. In this context, such numbers are called scalars, and this is scalar multiplication. To do this, we simply multiply each number in the matrix by the scalar. In this video, we introduced matrices and basic algebraic operations. You'll notice that although we discussed matrix addition and subtraction, we haven't discussed matrix multiplication or division. We will never divide matrices, but we'll come back to multiplication.